Alright guys, let's do a quick review about some addition and subtraction of negative numbers. So to start the review, we're going to first do a little review on what addition and subtraction are. So in our first example, 9 plus 4, just a basic addition problem, we know that the answer is 13. Because if you have 9 things and you add 4 more, you have 13 things. And we can see this pretty clearly on a number line. I'm just going to draw one number line for our entire set of problems today. So let's put 0 here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oh no, let's make it a little longer, 13, 14, 15 just for extra fun. So here's 15 on the number line. 1, 2, 3, 4, here's 5 on the number line. 6, 7, 8, 9, here's 10 on the number line. Those are some pretty good markers. And then over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see, 1, 2, 3, 4, 5. Here's negative 5 on the number line. Boop. And 6, 7, 8, 9. Here's a negative 10 on the number line. And let's go to negative 15. 14, 15. Negative 15 on the number line. Alright, so if we're looking at this addition problem, let me change the color of my pen real quick. Let's go red. Alright, so we start with 9 lemons. Right here. And then somebody gives us 4 more lemons as a birthday present, because if you're me, you love lemons as a birthday present. So you start with 9 lemons, and you go 4 more. 1, 2, 3, 4. There we are. That's the sum. 9 plus 4 equals 13 right there. 13. Super awesome. Basic, simple, easy. We know how to do this. Okay. Now let's look at problem number 2. 9 minus 4. Now, we can think about subtraction in 2 ways. 9 minus 4, we can think of it as 9, take away 4. So let's look at the problem that way. We start with 9 lemons. And then we use 4 of them in a recipe. So we're taking them away. 1, 2, 3, 4. That puts us at positive 5. We use those 4 lemons and we're left over with 5 lemons. Pretty standard subtraction problem, we all know this. So 9 minus 4 is 5, but there's one other way to look at doing subtraction. It's basically just a change in our terminology, or what we call it. Let's put 5 over here though, because we know we get 5. But we can also think of it as the difference. So when you're subtracting, you are finding the difference between 2 numbers. In addition, you're summing the numbers, but in subtraction, you are finding the difference between 2 numbers. And I'll show you what that looks like on the number line. So if you're finding the difference between these 2 numbers, you're finding the difference between 9 and 4. So we start at 9, and then over here is 4. And we want to know how many numbers are between 9 and 4. Well, if we count them up, 1, 2, 3, 4, 5, there are 5 numbers between 9 and 4. Therefore, our answer is 5. So, same answer, but it's 2 different ways of looking at a subtraction problem. I don't think I'm going to get rid of those red dots. Maybe I will. I'll just redraw this number line. Oh no! That was more than I wanted. Hold on while we troubleshoot. 5, 6, 7, 8, 9, 10, 11. This is a very bad number line. Okay, anyway, moving on. We're going to problem 3. Negative 4 plus 9. Now what are we doing here? Well, because it's an addition problem, we are going to sum the numbers negative 4 and positive 9. So the answer to this one, negative 4 plus 9, is 5, which you'll notice matches our subtraction problem up here. It's basically just the reverse. Like the numbers are switched from what we did in problem 2 to problem 3. The 9 moved here and the negative 4 moved here. But we can look at it as an addition problem if we look at it like this. So let's say we need 4 things. Let's say our recipe calls for 4 lemons, but we don't have 4 lemons. That's a problem. We are 4 lemons short, or negative. Well, we go to the store and we purchase lemons, but the lemons only come in a package of 9. So we purchase a package of 9 lemons. Now we have 9 lemons, and we go home and we use the 4 that we need in our recipe. How many do we have left over? Well, let's do this as an addition problem. We started with a need of 4, negative 4. And then we added 9 because we purchased 9 lemons. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer? 5. We have 5 leftover lemons because we added our need, our negative, to what we had, our positive, and it results in 5. Pretty standard. So let's look at the next one. Well, in this case, we are doing negative 4 minus 9. What are we doing here? Well, we're taking away because it's subtraction. And so we're going to have the answer be, oh, sorry, should have done the negative first. The answer is going to be negative 13. And let's look at on the number line why that is. So in this case, once again, we're starting at negative 4. Here's our negative 4. We needed 4 lemons. And then we had a genius idea. We were like, actually, I want to make 3 times the batch of this treat that I'm making. So suddenly you need even more lemons. And so when you're looking at the recipes and you're figuring out how many you need now, because you're calculating like, I needed 4 for this recipe and more for this recipe and more for this recipe, well, suddenly you need even more lemons. So let's find out how many more lemons you needed. So in this case, we're taking away 9. We didn't have 4, and now we have even less because we need more. So let's go negative 4, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9's right there. That means that we now need 13 lemons. So we have negative 13 lemons in order to make the recipes that we have decided we want to make. So it's an interesting problem because, as you can see, we're subtracting, we're taking away. We started with a little less need and we ended with more need, so we took away. But as you can see, it also matches the addition problem here, because when we're subtracting negative numbers together, it adds up to the negative, if that makes sense. We started here and we added even more that we needed, and so we ended up over here. Hopefully that isn't too confusing. We are still just taking away as in a standard subtraction problem, but because it's on the negative side of the number line, it's a lot like we're adding. Just if we had positive numbers, it would have been adding. Okay, moving on to number 5. 9 plus negative 4. Now what is happening here? Are we adding? Are we subtracting? What's the negative telling us in this case? Well, I'm going to just tell you the answer up front, and then we'll look at it on a number line. So we have 9 plus negative 4. Now we have a positive and a negative next to each other. We can think of this mostly as just a subtraction problem. So this problem would become 9 minus 4. And that's how we could rewrite the problem, so we don't have a plus and minus right next to each other. So positive and negative together, this is a rule you should remember, positive and negative together, it equals a minus, or subtraction problem. Okay, but why is this happening? Why can we just get rid of the positive? Well, let's look at it on our number line. But first, let me answer the question. 9 minus 4 is, of course, 5. Doop. All right, and you can think of it because we are doing an addition problem, right? So we're adding these two numbers together. We're adding 9 and negative 4 together. And when we add negative 4 to something, it's like saying, okay, I have 9 lemons, and then I decide to make that recipe that requires 4 lemons, and so now I don't have as many lemons because when I added in that recipe that needed 4 lemons, I ended up with less lemons. It's a little bit funky to do it like this, and in everyday life, we typically don't have to deal with a plus and a minus right next to each other. When we get into more complicated algebra problems, it sometimes turns up and we just have to know how to deal with the plus and the minus right next to each other. So let's look at it on the number line though. Let's see, we're at 9. and we're just sitting around with 9 lemons on our counter, and suddenly we have a genius light bulb moment. Here's a little light bulb. Ching, ching, ching. I have an idea. I want to make something with lemons. So that genius light bulb moment could be considered our positive. We're like, I have a thought. And we're like, okay, my thought uses 4 lemons. And so now we're going to go 1, 2, 3, 4. Take away those 4 lemons. That takes us to 5. Just like a basic subtraction problem. So in this case, we're just adding like one extra step into our brains. It's like, oh, I have a thought. And then that thought takes away the lemons. Hopefully that explanation makes sense. The basic rule that you just need to remember is positive and negative together are basically like a subtraction problem. Because when you take a negative 4 away from a positive number, we are subtracting. Alright, and then let's look at problem 6, final problem on this. 9 minus negative 4. Well, what are we looking at here? Is it an addition problem? Is it a subtraction problem? Is it a problem that's just going to blow our brains? Don't worry, it's not too hard. Once again though, we have a basic rule that you need to remember. When you have 2 negatives together, the answer becomes positive. So in this case, this would be 9 plus 4 equals 1. And this can be a little confusing. It's probably the most confusing concept. Why do double negatives, or 2 negatives or subtraction signs together, make a positive? Well, let's look at it. We can think of it 2 ways. So let's look at the way Cody thinks about it, and then we'll look at it a slightly different way. We start at 9. Choop, choop. Well, we're currently at 9. Okay? But 9 is not our peak optimal position to be. Because 9 is a state when we've already taken away 4. So let's say that you have a balloon. This is the way Cody thought about it. You have a balloon. And it has a string that has a rock attached to it. The rock is weighing it down. So it's floating here at a 9 level. So it's still positive, it's still floating, but it has a rock on it that's weighing it down 4 points. Well, if we cut off that rock, we take off that negative 4, we take away the negative 4, well, where's that balloon going to be floating now? Well, it can raise up 4 more points because it doesn't have that heavy weight on it, and suddenly it'll be floating at 13 because we took away the negative. So when we look at this on a number line, if we take away the negative that's weighing us down, then we go 1, 2, 3, 4. Oh, I'm at the wrong spot in 9. I should put 9 on the right spot in this number line. Here we go. 9's over here, and then we go 1, 2, 3, 4. We took away that negative, and that landed us at positive 13. Dun dun dun! Okay, so that's one way to look at it. We can think of it as we are at a number, but we could be at a more optimal number if we took away our negative, and that would make us a positive, or addition problem. The other way to look at this is to remember that subtraction is the difference between 2 numbers. So when we see that subtraction sign, we're looking at the difference between 9 and negative 4. Well, what is the difference between 9 and negative 4? Let's see. I am teaching math.
You are?
Yes. In a minute. Negative 4. And then 9 over here. Well, what's the distance, or the difference, between those? How many numbers do we have between negative 4 and 9? Well, the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 numbers between 9 and negative 4. And so, because it's 13 numbers between 9 and negative 4, the answer to this problem is positive 13. So those are two different explanations for why 9 minus negative 4 could be written as 9 plus 4 and would equal an addition problem, and the answer would be positive. But if you don't want to remember the explanations and you just want to remember the rule, then the basic rule that you need to remember, your takeaway from this, is that when you have a positive right next to a negative number, the answer is still going to be negative. And when you have a negative right next to a negative, it's going to be positive. Alright, that's all for today. I will see you in the next video.